Okay, we now have the last chapter, which is about numerical integration. Here we talk about how to find the integration of function approximately if we couldn't find the integration analytically. For example, here this integration couldn't be done analytically. It's difficult to find it analytically. It's impossible actually. Here, what we do, we need to use a numerical method to find the value of this integration. Okay, even if we have, let's say, the integration of e to the power x squared dx, we cannot find this integration. Okay, what we do, we have some numerical methods for evaluating these type of integrals. For those integrals that we couldn't find them analytically, yeah, we have these methods for finding them. First, we have Newton-Cotes formula. We have two methods, trapezoidal rule and Simpson's rule. Here, Simpson's rule, we have two methods here. Simpson 1/3 and Simpson 3/8. So we have trapezoidal rule and also Simpson's rule. Simpson's rule has two rules. Okay. And then we have Romberg integration and also Gaussian quadrature. We have these methods that we study here for evaluating an integration approximately. First we have trapezoidal rule. For trapezoidal rule, what we do, trapezoidal rule is an approximate value of an integration. Here, the integration of this curve from A to B is this area. Oh, okay? It's the analytical solution. But here, for the function f, we couldn't find the integration analytically. What do we do? Here, trapezoidal rule is the area of this trapezoid. Okay? This is a trapezoid shape. We find this area. Look, it's approximately the same as the area of the area of the region analytically. What's the error here? The error here is this one. Okay, this is the error. What we do here? Here it's okay. We say x naught to find the integration. Let's say f of x dx from a to b. X naught is a, xn is b. This is xn and this is x naught. X naught is the least value of the is the lower limit of our integration, and xn is the upper limit of our integration. Then what we need to find, we need to find h, which is the step size, okay? We let k, xk is x naught plus kh. Yeah, as you see, this is x naught. X naught plus h is x1, plus h is x2, plus h is x3, x4, and so on. Okay, look, from x0 to x1 we have h, from x1 to x2 is h. This is our step size. Okay, if we are asked to make our interval, if we want to make the interval AB into n equally spaced intervals, if we make it into n equally spaced intervals, what we do? We say h is b minus a over n. N should be given. N or h should be given in the example. Okay? We need h actually. We just need h. Okay? If it's not given, so n must be given. We just say b minus a over n, it's h. We need to find the values of xi, x0, x1, x2 up to xn. We say the integration of f of x dx is, let me explain it here. If we have this curve, if this is A and this is B, if you want to find, or if you want to evaluate the integration of this function, this is f of x, from A to B, approximately, by using trapezoidal rule, what we do, we need to make it to n subintervals from A to B. Let's say it's x0, this xn. Okay, that's x0 and B is xn. Let's say h is, okay, we don't need now here. Let's say it's x1, this x2, this x3, this x4, x5, and then this is x6. We have these. If we want to make this into 6 subintervals, okay, from x0 we count h, and so on until we get the upper limit of our integration. Now, to evaluate this integration by using trapezoidal rule, what we do? We need to make 6 trapezoidal shapes. Look, it's like this. Then we have this. Sorry. Okay. That's it. Then for x3, for x4, it's like this. And then this. Okay. We have 1, 2, 3, 4, 5, 6 trapezoidal shapes. This 1, 2, 3, 4, sorry, 5. We have 5 trapezoidal shapes. Okay, so it's 6, not 5. And you have this also. That's it. Now, look, we need to find area of these trapezoidal shapes. Area of these trapezoidal shapes, which is the approximate value of our integration. Look, these are errors. Let me check. Let me stay. This is the error. This is error. This is error. This is error. That's it. We have this error. Okay. So the analytical integration أجيب analytical videos أو أنا شتيا أو ما وش نشتيا همي integration همي area كيا بلام كاتك تبى trapezoid videos أو هني تياني إما approximate solution مثلا سطلة سط analytical كان هي نية لو أنا كم تبي يعني زي تبي. Okay. Now we say the integration of f of x from A to B dx is the integration of f of x from x0 to x1. I mean area of this part. Okay, from x0 to x1. Then plus integration of the function from x1 to x2. Then plus integration of the function over this region, this and this. Okay? It's the sum of these all integrations. Then we get the integration. And here, I'm just going to give you the rule of trapezoidal rule. I mean, the final, this one is. Yeah. We say the integration of f of x from a to b. أمريكا هاي هم اشتقاقي يا ساكن. Please ناكي اشتقاقي بسالي. Okay? You just need to know, you just need to use the rule, nothing else. Okay? We say it's h over 2. H over 2. F of x naught, when it's as it's written f naught means f of x naught. This is fn means f of xn. Okay? We say f of x naught and f of xn. Here we have no coefficients for these. For all the others, we have 2. We have 2. Okay? We have 2 for all the others. It's h over 2, first and last, then plus 2 times all the others. لأن if أنا كمان fx1 fx1 fx2 fx3 تأكد. Okay? لأن if كان أدوزينه fx1 fx1 fx2 هم يدوزينه كدوزي معنا دين شكين fx1 fxn واتيا كم دانا كوتا دانا هيك ضرب جماري الناقي ولم أواني هم يسوي دوبي. Okay? Then we find the sum of them, we get the result. Okay? This is the rule of trapezoidal rule. Or it could be written in this way. H over 2, f naught plus fn plus 2 times all the others. Okay? This is the rule of trapezoidal rule. Then, it says approximate the following integral using trapezoidal rule with h to be 0.5 and h to be 0.25. H to be 0.5 and h to be 0.25. What we do here, from 1 to 4, we need to find all xi's. Look, x naught is 1. How about x1? x1 is 1 plus h. Okay, our step size is h. What I do in your hand, x h. So it is 1 plus 0.5 for this one first. 1 plus 0.5 is 1.5. Then x2 is 2 because we add h again. Then x3 is 2.5. x4 is 3. x5 is 3.5. x6 is 4. Look, this is the upper limit of our integration. We stop there. We stop there. Okay? Now, we have these values of x. We have x0 up to x6. We need to evaluate these all into this function. We need to find f of x0, f of x1, up to f of x6. What's f? F is this function. This is f of x. We need to evaluate these values of x into the function. Okay? Then check instead integration get madra ph x can do in the first step we need to find the values of xi's. Okay? x0 is the lower limit of our integration. We start from there. It's the lower limit of our integration. We start from there. Then we add h to it to get x1. Again, we add h to get x2. We add h to get x3 up to we get the upper limit of our integration. Attach variable. Okay, here the upper limit of our integration is 4. That's why we stop at 4. Okay, that's it. Now that's it. This is x0. This is x6. As you see, our step size is 0.5, 0.5, 0.5, 0.5. We just add 0.5 to each x to get the next x. Now, what we do, we said the first one and the last one, we just evaluate them. Okay? We just evaluate the first and the last one. Where? Into this function, into the given function. This is the function which is in the integration. This is f of x. We evaluate all the x values into this function. Okay? To this function. This is f of x0. And this is f of xn. We put them both together in a column. Okay? Because in the rule, we don't multiply these two by any value. Their coefficients are 1. And all the others together, because we multiply these all by 2. In the rule, as I said, that's the rule. That's it. The first one and the last one is without 2. But all the others should be multiplied by 2. Okay? That's it. كواتليرا بيسا يكم أخير بيكو بجاب سميك الكاتك هم أوانيش بيكو أما نزار فيديو كين أخيرا أما نش بيكو كوي كينوتا هموشي إيش دسردوتا. Look, we say the integration is this one, which is h over 2 f0 plus f6. This is f6 because it's the evaluation of x6. Okay, this is f6 and this is f0. This is f1. This is f1, f2, f3, f4, f5. Okay, we multiply them all by 2. We multiply them all by 2. We have h over 2. H is 0.5. It's given. It's 0.5 over 2. f0 plus f6 is this one. The sum of all the others, as you find, look, we found here. This is the sum of these all. And the sum of these two is 1.861. We just multiply this by 2, we get the result. Okay? ليرة جرين جوتوب ثاني شون إكسكان دوسي توصلها كإكسكان دوسيو هم يلنا نقشة كاداب نيرو in the function هم يلنا function كاداب نيرو بودوسي نو إن كانيا يكمل كوتا ضربي شيء مكان أوان كهمون ضربي دوب باش طبعا كو أنا كده دواتر إيش دسر دو ضربي هم يعني كده system that's it. That's so easy. Okay, this is trapezoidal rule. And here in the example, it says for h to be 0.5 and h to be 0.25. For 0.25 is the same. Our step size is 0.25. Let's check. We always start from the lower limit of our integration. We start from 1 here because the integration is from 1 to 4. We go up to 4. 1 plus 0.25 plus 0.25 plus 0.25, 0.25 up to 4. Okay? Now we evaluate these all the values of x into the given function. Okay? We just replace x by these values. What we get? First one and last one together in a column, and all the others in the other column. f of 1 is 0.4472 and f of 4 is 1.4142, which is 1.8614. This is the sum of these two. The sum of these two is 1.8614. Then, for the others, f of x1 is this one. Sorry. F of x1 is this. F of x2, f of x3, f of x4, up to f of x11. Okay? That's it. Now, we find the sum of these all. We find the sum of these all. Okay? Which is 10.6364. 10.6364. We now put these two into the function. We say f0 plus f12, the same. And we multiply the sum of the others by 2. So this is this plus 2 times this, all multiplied by h over 2. H is 0.25, which is 2.8918. This is the answer of the integration, or is the evaluation of the integration if we have 12 equally spaced. So if we have h to be 0.25, okay? But the above one, this is when h to be 0.5, the same procedure, only h is changed. Certain element. As you see, by increasing the number of subintervals or by decreasing the step size in the first one was 0.5 and in the second one is 0.25. As much as we take a smaller h, we get more accurate value for the integration. Okay? حتى h بشكل البيت نرخي integration كمان زيادة accurate. Okay? Yes. Here you have these two exercises. Then we have Simpson's rule. And just go on to the rule. Okay? Let me check the rule. That's it. Look, Simpson's rule, Simpson 1/3. We have two types of Simpson, 1/3 and 3/8. Okay? For Simpson 1/3, we say this is the rule. H over 3 times f0 plus fn. These two without multiplying by anything. It's the same as the previous one. We don't multiply f0 and fn by anything. And then 4 types of the odd ones and two times of the even ones. Checking أول وأخير كوتا يكمل كوتا ضربي شناهي دو ضربي جوتا كان شو ضربي تاكا كان. What are the odds and evens? The evaluation of an odd value of an odd index of x is odds here. For example, this is f of x1. This is an odd index of x. This is f of x2. This is f of x3. This is f of x4. And so on. We multiply the even ones by 2 and the odd ones by 4. And the procedure is the same as the previous methods. That's it. Look, f0 plus fn, here we have h over 3. f0 plus fn, 4 times the odd ones and 2 times the even ones. That's nothing. And then for Simpson's 3/8, the above one was Simpson 1/3. It was Simpson 1/3. And for Simpson 3/8, here, this is the rule. For 3/8, it's 3h/8 f0 plus fn. 3 times these, and 2 times all the 3 multipliers. How? We say it is, let me write that, it's 3h/8 f0 plus 3f1 plus 3f2 plus 2f3 plus 3f4 plus 3f5 plus 2f6 plus answer. Look, we say first and last fn without multiplying by anything. The 3 multipliers, f3, f6, f9, f12, okay, those multiplied by 2. Chanjara can say, like and others multiplying by 3. Okay, all the 3 multipliers is multiplied by 2, and the rest multiplied by 3. Okay, that's it. This is the rule. Look at this example. It says approximate the following integrals using Simpson's 1/3 rule with h to be 0.5 and h to be 0.25. So we need to use Simpson's 1/3. In Simpson's 1/3, we said first, last, 2 times the even ones and 4 times the odd ones. That means we have 3 types. We make it into 3 categories: first and last, odd ones, and even ones. Okay? Yeah, h to be 0.5 and 0.25. For 0.5, this is 1, 1.5, 2, 2.5, 3, 3.5, 4. Why do we stop at 4? Because our integration is from 1 to 4. We must start from 1 and we stop at 4. Then, as I said, we make it into 3 categories: first and last. This is the evaluation of 1 into the given function, and evaluation of 4 into the given function. First and last. We find the sum of these. We don't multiply these by any value. Then, the even ones, so the odd ones together. This is f of x1. This is f of x3. This is f of x5. Okay? As you see, this is x0, x1, x2, x3, x4, x5, and x6. The odd ones together and the even ones. Okay? Now, we find the sum of these all, which is that value, and finding the sum of these two, which is this value. Now, we say it is h/3 multiplying by first and last, which is 1.8614, plus 4 times the odd ones. These are the odd ones. It's the sum of odd ones. We multiply these by 3. Okay? Plus 3 times 2.8982 plus 2 times the even ones. Okay? The last column is the sum of all even ones. Okay? Which is 2 times 1.9544. Just evaluate this. And here h is 0.5. Evaluate. So you get what it's. That's 4 times the even ones is the odd ones, and 2 times the even ones. Okay? And the final answer is 2.8925. This is for the case if h to be 0.5. How about if h to be 0.25? The same procedure, but we have more x values. That's it. This is x0. x1 is x1 plus h. We add h to x0, we get x1, which is x1, x2, x3, x4, x5, x6, x7, x8, and so on. Okay? Now, as I said, in the rule, we have three types. First and last, even ones, and odd ones. Okay? So we need to have three columns. For first and last, this last, and this first. These are evaluations of 1 and 4 into the given function. Then, for the odd ones, x1, x3, x5, x7, and so on. All are in a column. Then, for x2, x4, x6, x8, and so on up to the end. Now, we find the sum of these two. What's this? Then, the sum of these in this column. And the sum of these in this column. Put it here and here. If we make this table, it's easier to find the solution. I mean, to get the results. Here, we say it is h over 3. H is 0.25 here. Times. First and last is 1.8614 plus 4 times the odd ones. These are the sum of odd values. Okay? 4 times this. 5.7878. Okay? Then 2 times the even ones. Just evaluate this, you get this. Okay? You need to use calculator to get the results. That's it. This is first and last. 4 times odd ones and 2 times even ones. And the result is this. Okay? Here we have another example. It says approximate the following integrals using Simpson's 3 over 8 with h to be 0.25. It's the same procedure. If we have the rule, it's easy. Okay, look. The rule is first and last. Then 2 times 3 multipliers. I mean x3, x6, x9, and so on. Okay, and 3 times all the others. So how many categories do we have? 3. Okay, we need to have 3 columns in the table. Look, the function is from 1 to 4, and h is 0.25. So we start from 1 and we go 0.25 till we get 4 for finding all the x values. This is x0, x1, x2, x3, x4, and so on. Now, let me write down here. This is x0, x1, x2, x3, x4. That's it. As I said, first and last together. F of 1 is this. This is F. لم نخشى داني نحن شهمون نخكاني X لم نخشى داني أو نخشى كيف ما أدري أنت ليش يجوز. The function is this one. Okay. This for x0, f of x0, and f of x1 is this value. And then for three multipliers, we need to find f of x3. This is f of x3, and for f of x6, and x9, these are three multipliers. We have no anymore three multipliers to evaluate. Okay, here we have x12, but x12 is the last one. Okay, it's not among the three multipliers. That means we don't multiply it by 2. Then for all the others together, these two, and these two. We evaluate all the x values and put them into the category in their columns. Okay. Now we find the sum of these, and these two. Okay. These are their sum. This is three multipliers. This is all the others, and this is first and last. We say it's 3h over 8. First and last. 3 times these and 2 times 3 multipliers. Okay, this is 3 multipliers. We multiply these by 2, and this by 3, and this by nothing, and we find the sum of them multiplied by 3h of 8. H is 0.25. This 3 over h. This is f0 plus fn. This 3 times those, and 2 times 3 multipliers. Then we evaluate it, we get the result. That's it. Okay. It's so easy. Just evaluation. Okay. It's just evaluation to the function. Nothing else. x0 is given. H is also given. Okay. Start from x0 and go by h to get xn, which is the upper limit of our integration. Here in this example, it's 4. So we get 4. And we get these values of x. These values of x. Now, evaluate these values of x into the given function and put them into the rule. You get this. This is the rule. That's Simpson's rule. Do you have any question about trapezoidal rule and Simpson's rule, 1/3 rule and 3/8 rule? Do you have any question? So if we have the rule, it's easy to evaluate. I will ask the course coordinator if it's provided or not. Okay. I will ask him. No. Okay. I will ask him and I will let you know if this provides or not. Okay. We now have Romberg integration. In Romberg integration, we need to make this table. Let me show you the table first. That's it. We need to make this table. Okay. In Romberg integration, we need to make this table. To make this table, I'm going to tell you how to make it. That's it. Look, if we start with one subinterval, if we have only one subinterval, okay, we say h1 is b minus a. It's b minus a. This is h1. And R11 is h1 over 2 times f0 plus f1. As you see, if we have only one subinterval, this is x0, this is x1. AB. That means if you have only one interval. So this is x0 and this is x1. You have only two x, which are x0 and x1. If you have only this interval. H is the length here between A and B. The distance between A and B is H1. Then for finding R11 is H1 over 2 times F naught. What's F naught? F naught is F of X naught. It's F of X naught plus F1. F1 is F of X1. So if we put these two into the given function to get F naught and F. This is R1. Then if you have more than one subinterval, let's say if you have two subintervals, let me check. Let's check if you have two subintervals. Let me write down here. If you have two subintervals, let's say here we have A, B. If you have two subintervals, means here we have an X here. This is X0, X1, and X2. This is an interval, and also this one is an interval. As you see here, we have two intervals, X0 to X1, and X1 to X2. Okay? We have these two subintervals. And here we have f x naught. F naught means f of x naught. F1 is f of x1. F2 is f of x2. Okay? It's f of x2. And h2 is a half of h1. What was h1? H1 was from A to B. And here we make it into two subintervals. Okay? We make it into two subintervals. Say H1 لأي بوبي أما وهم يب. أي H2 شنية. H2 length أم subinterval تازانية. Length أم شنية. نيوي بيشتنية. It's not the half of this one or no. And this one is a half of this one. Okay, it's a half of the previous age. Now, you see, we have R21. R21 is H2 times 1 over 2 F naught plus F2 and then plus F1. We multiply the sum of these two by a half and then plus F1. Okay, plus F1. This is R21. We now write down R21 based on R11. So R21 is, say, that's it. R21 is equal to R11. We already found R11. We already found R11. This is the first R11 that you found. That's it. This is R11. We need to find it. It's H over 2 times. So H1 over 2 times F naught plus F1. As you have only two X naught and X1. Here we have only one subinterval. Okay, here this F naught, F1. The sum of these two multiplying by H over 2. This is R11. Then R21 is equal to a half of R11 plus H1 F1. H1 F1. What's H1? Is the length from A to B. Okay. F1 is F of X1. This is for R21. This is for R21. But be careful. This F1 is not the same as the previous one. this F1 is here, as we have R21, we have, it means we have two subintervals. This is X0, X1, X2. We need to find F of this value. Okay, here this is F1. Then, for finding R31 is half F0 plus F4 plus F1 plus F2 plus F3. All multiplying by H3. And we need to if we need to write down based in terms of R21, R21 is the one that we found before. Okay, up to now we found two R11 and R21. And forgetting R31, we say this R21 plus H2 multiplying by this sum. Or you can use this rule. Or this one, which is a half R21 plus H2 times F1 plus F3. F1 plus F3. Generally for Ri1, it is Ri minus 1 and 1 plus Hi minus 1 multiplying by this summation. And also you can use these rules, this rule, for finding all the R's. Okay, first you need to find the first two R's, and then we use this rule to get all the other R's. Okay, that's it. R22 is 4R21 minus R11 over 3. Then R32 is 4R31 minus R21 over 3. So we need to find 3R. R11, R21, and R31 by using the above rules. Okay? As you said, R11 is H over 2 F0 plus F1. R21, sorry. R21 is let me check, it's half or H over 2. It's a half. So it's a half R11 plus H F1. And then for R31 is this. This one is. This is R3. R31. We need to find these three. Based on these three, we can use these rules for obtaining all the other R values. R22, R32, R33, and R44. Okay? We can find these all and to make this table. Look at this example. In this example, it says, use Romberg integration to approximate this integration. Okay? This is our integration. We need to evaluate it. This is f. This is f of x. This is x0 and this xn. It says compute the Romberg table until Rij minus Rij minus 1 is less than 0.305. Okay, until we get this, we need to be continued. Let's find. Here, R11 is H1 over 2. H1 is, what's H1? H1 is the length of our interval. It's from 1 to 4. What's the length here? H1, we need to make this into one interval, one subinterval. From 1 to 4, the length here is 3, is it? H1 is 3. From 1 to 4 is 3 units. Okay? So this is H1. H1 over 2. And X0 is 1. X1 is 4 here. for this interval, as you have 1 and 4, we have only one interval. Okay? From 1 to 4. This is x0, this is x1. You have no more x. f0 plus f1. Evaluate these two, I mean 1 and 4 into the given function, you get these two. And the result is 3 over 2. That's value. Okay? And here we get 2.7921. This is R11. This is R11. Okay? Then to find R21, we say it is a half. R21 is a half R11 plus H1 F1. But here F1 is not the same as this F1. Be careful with that. Okay? R21 is what? Here. F1 here, as you see, for R21, we need to have two subintervals. For R21, we need to have two subintervals. This is X0, X1, X2. This is A, this is B. A is 1, it's 1, and this is 4. So what's the midpoint of these two? It is 2.5. Is it? That's 2.5. So this is F1. We need to find F1 is F of 2.5. Okay? We need to find that. Now, we say it's a half R11, we already found it. H1 is the previous H. It's 3. Okay? Is 3 times F1. F1 is F of 2.5. Just evaluate. You get the result. It's 2.867. This is R2. This is R21. Then, to get R22, what we need to find, how can we get, it depends on R21 and R11. It only depends on R21 and R11. We use the rules, okay? It's 4R21 minus R11 over 3. We already found these two. Which are these two? Dividing by 3, we get this. Now, we subtract these two, R22 minus R21. Is less than this or not? No. Then we continue. Why do you subtract these two? You got the table. We need to find these two. We need to find the subtraction of these two. And if it's not true, if it's not less than the given value, we continue till we find this. Then we subtract these two. Okay? If it's less than the absolute value, I mean the given value, so we stop here. If it's not, we continue. That's what this is. So it's greater than the given value. So we need to continue to get R31. We need to use the rule. Okay? A half R21 H2 times F of X1 plus F of X3. But for obtaining this, we need to make the interval into 3 subintervals. Okay? This is X0. This is, we don't know which X is that. But it's A to B. If you need to make it into 3 subintervals, so it's 1. This is 3 subintervals. Is it? Here you have 3 subintervals. Now, this X0, this X1, X2, X3. X0 is 1. X3 is 4. Okay? If you need to make it into 3 subintervals, so what's our step size? What's our step size to get 4? Here, we say from 1 to 4, we make it into 3 subintervals, or we divide by 4. Okay, so it's 3 divided by 4 is 0.75, so it's 1.75. Okay, sorry. R31, so it should be 4 subintervals, not 3. Sorry for that. It should be 4 subintervals. 1, 2, 3, 4. There's 4 subintervals. This x0. Then x1, x2, x3, and x4. How to get the step size? This is 1 and 4. We say 1 and 4 is 5, or we subtract them and divide by the number of subintervals. Okay, we say 4 minus 1 over the number of subintervals is 4. It's 3 over 4. That's 0.75. That means this is our step size. The first we start from 1, and then this is 1. It's 1.75. Then 2.25. So 2.5. If you add 1.75, if we add 0.75 to this, we get 2.5. Then 3.25. And finally, we get 4. Okay, this is x0. x0 is 1. x1 is 1.75. x2 is 2.5. x3 is 3.25, and x4 is 4. That's it. Then we find these values, f1 and f3, are these two, f of x1 and f of x3. These two x values, not the previous ones. Okay? And then we get a half R21 plus H2 times F1 plus F3. And that's it. This is the final answer. And this is R31. This is R31. Then we need to find R32. Look, we just need to find, by using these rules, I mean this type of rules, we need to find R11, R21, and R31, nothing else. Okay? By these rules, we need to find these 3 R. And we use these type of rules to get all the other R's. Okay? Here, for R32, it's 4 R31 minus R21 over 3. And is 37. Now we subtract. It's still greater. We continue. R33. We find it. It's 16 R32 minus R22 over 15, and is 37. And we get, as you see, we get 0.4 O's and followed by some numbers. So it's less than 0.0005. This is less than it. The subtraction of this is less than the given value. So we now stop here. We stop here now. What did we find? We found R11, R21, R22, R31, R32, R33. We found these all. Okay? We put this into the table. As it says, make the table. Here, for one subinterval, I is the number of intervals. For one subinterval, the length is 3. For 2 subintervals, the length is 1.5. For here, we say it's 4 subintervals because it's 2 to the power I minus 1. Okay? This is the number of subintervals. If it's 1, we get 1 subinterval because it's 2 to the power 0. If it's 2, we get 2. And if there's 3, we get 3 minus 1 is 2. 2 to the power 2 is 4 subintervals. And if it's 4, It's 8 subintervals and so. And it's here for 4 subintervals, the length is 0.75. This is R11. This is R11. This is R21, R22. Okay? And R31, R32, R33. The subtraction of these two is less than the given value. So you stop there. Okay? And we say that value, I mean, the final value of R that you found is the evaluation of our integration. It's the evaluation of our integration, the final value of R. And it's the end of this chapter. If you have no questions, you take a break, then you'll take the quiz. Do you have questions? Okay.